Hi there. Today's going to be a little bit different video. I'm going to spend some time going over the design of the aquaponic system, and we're just going to stay in the CAD program that I use to lay everything out. So either this is going to be very exciting because you can see some of the details, or very boring because you can see too many details. This is all drawn out in Autodesk Inventor 2016. I've been using CAD software throughout most of my career, so I've been comfortable doing this. A lot of people can use SketchUp or some other CAD programs, but since I know Inventor, this is what it's drawn out with. Overall, I wanted to draw it out in Inventor so that I could get the hoops drawn in and do the layout of everything to make sure that it all fits in and fits underneath the hoops. I even drew in some of the people just to make sure I had some spacing right and proper headroom and whatnot, so they could walk around in aisles and not hit their head against the roof. So this is the overall greenhouse. It's a 26 by 148 foot what most people call a hoop house. It's a Gothic arch style, which is good for our area for shedding snow. And then on the tail end, there are two 48-inch fans that are drawn in here, used to exhaust the hot air out of the greenhouse. And then on this side, get scrolled over to it here, is three intake louvers. There's a doorway entrance here, and then there's plans to put in a evaporative cooler, which I have not installed yet, but I wanted to make sure I had enough room between the intake louvers, the evaporative cooler, and some space between the tanks so that the airflow could get into the greenhouse properly. So let's turn off the greenhouse just so we aren't looking through all these hoops all the time. And the cooling system. And so here's the overall system design or system layout. We'll turn off the people too. Not much need to have people in here. All right. And this is the overall layout of the setup. I'll try not to get you too seasick watching me scroll through and pan around a lot of these, but it can be difficult if I'm rotating things around a bit. So overall, there are three deep water culture beds. All of them are 98 feet long. There's an 8-foot wide, a 4-foot wide, then there's an aisle that allows people to access the entire greenhouse, and then one last 8-foot wide one. And then this area are some media beds, which are also being used as some of the biofiltration. And then this area are the tanks and the filtration setup. So let's start with the beds, and I'll show you how that's all working. The inlets of the beds, which are accepting all the water from the media beds, there's a whole bunch of different valves and whatnot on here. It's not overly complicated. The first phase of the design will be to just have the water come in and then go into this first deep water culture bed. Eventually, when I build the other two beds, the first bed, I'll then open up this set of valves, keep this one closed, and then the water will come in and essentially run parallel down these two beds and head down to the left here. If I wanted to, I could adjust these valves and get the flow to work a whole bunch of different directions. That's why these are all in here. For a small investment up front, it's better off trying to get the plumbing installed so that you can make changes to the system without having to cut and redo everything. Long term, there won't even be any water going down through this pipe. And I did have this one go underneath the floor of the greenhouse just so it wasn't a tripping hazard for people coming in. The entire system is designed to be above grade. There's no sump tank or anything. The deep water culture beds are actually acting as a sump tank. And then long term, once this bed is in, the water, once it heads down this way, it will all come back through this bed, come through this valve. This section's shut off, as I just said. And then there's going to be the pumps here that will pump the water back to the tanks, and I'll cover that in a minute. So let's head down to the other end of the beds. So these beds, the outlets will come out through here, and initially, like I was saying, because this is going to be the only bed that's up and running, the water is going to come out of here, this valve will be closed, this one will be open, and the water will go to here, and there'll be a pump, and then pumps back to one fish tank. And I didn't draw on the pump, I just didn't have the diagram for it and didn't feel like drawing one out. And then, like I was saying, long term, both of these beds will be installed. The water will then flow this way and then come into this bed. And with all these different valves, it makes it much easier to isolate a bed if I needed to shut one off for cleaning it out. I can still keep the rest of the system up and running and just drain out one bed if I needed to, or just clean it out and get it all mucked up. So you can see the water does go underground here, just a small trench dug into the floor just so people don't trip over it. And then this is the return line heading back to the fish tank. Coming back to the end of the outlet here, like I was saying a few minutes ago, the water will come out through this pipe, and then we'll catch two pumps that are here. And then there are two return lines heading back to the fish tank. So if we follow that back, oh, and by the way, not everything is clear. I just have it drawn out and clear just so it's easier to see sort of what's happening in the background. I can adjust those views and make it so everything is much clearer to see, but then you sort of lose track of what's happening behind you. So I sort of like to make everything a little bit translucent here so you can sort of see the overall picture. But anyway, these two lines come back to the tanks, and then there's this valve with a pipe going between these two. And what this will allow me to do is have the two pumps running, so essentially one pump is filling their own tank. But if I need to take a pump out of service for maintenance or if it breaks or whatever, I can continue to have the system running. I can take one pump out of commission, which would essentially stop the water flow in one of these pipes, and then open up this valve between the two tanks so the water could come up here, go into this tank, also flow this way and go into this tank. So it's half the flow going into the tank, but I'm not shutting down the system at all. Alright, so we'll zoom in on the details of one of these tanks, and I'm just going to open up the file for just the tank so we don't have to look at everything else. Now these are 1,350 gallon tanks. I went with this size. I like the larger size tanks. A lot of setups you'll see that they'll do a tank that's this dimension, but it's usually built up on a stand because you need enough water head height to get the water down through the rest of the system, to the filters and the media beds and down to the deep water culture beds. But instead of building stands, I figured it's easier just to have a taller tank, and it gives the fish a little bit more room, get a little bit more water mass in the system to keep your temperature stabilized a little bit. And that's what I have in the current dome, and it's worked out really well over the years. So this setup has a spray bar along the top. Again, I did that the current setup. Whoops. And I really like having a spray bar in there. It's used to help aerate the water a little bit, and it forces the water to swirl in a particular direction. I just didn't draw all the little holes in here, so the intake is here and it sprays out in one direction here, sprays out in the other direction here, and it's just capped on the end. I know a lot of people, they'll say that the spray bars will clog up. Mine has never clogged up. I'm basically always pumping clean water through that's been filtered, so I haven't had any debris get into these clog up the holes. And if it did clog, it's not a permanent connection on the inbound part. I can just pop it off and clean it out if necessary. And this is pumping water in at about 1,200 gallons an hour, so I'm exchanging the water in this tank just shy of once an hour. Actually, a little more than once an hour. Sorry, a little backwards. So the tank has a 1.5 inch solid lifting output. Most people just call it a slow, where there's this fitting on the bottom, and I cut it so it looks like a castle crown. It acts as a filter so that the fish don't get sucked up into the pipe. The water comes up through this pipe, out through this way, and then out through a bulkhead fitting in the side of the tank. And there's a gate valve here where I can adjust the flow or shut it off if I had to do maintenance downstream. And then this one pipe here sticks up to act as an air brake, so that way if this was just closed off, you could get a siphon effect and start siphoning your water out of the tank. So this acts as an air inlet, so the water level of the tank is just forcing the water out, and it's by that head pressure pushing it out, and it doesn't create a siphon. I also made it tall enough here where it essentially just touches the spray bar, and that's used just to help support it to keep it from bowing. It was there, so I just stuck it onto there. So not all the water flow is coming out of this tank. It's just the 1.5 inch pipe, so it's just enough to suck the solids off the bottom. I like to go with the smaller pipes. Some setups will do a much larger 3-inch pipe, but if you get some heavier debris in there, it can just sort of tumble around in the pipe because there's not enough velocity to force that out through here. So I like a little bit smaller pipe in here. And then this tank uses the Cornell style method of water removal, I guess for lack of better terms, where this is skimming the water off the top of the tank, and that's where most of the cleaner water already is, so there's not much need. There's hardly any solids that work out this way. The majority of them are coming through the solid lifting output. So essentially we're just skimming the water off the top of the tank, and that's essentially clean. I wanted to show just a little cross profile of how this works. There we go. So the water level in the tank is right at the edge of this overflow, and this is a 4-inch, a 3-inch reducer. It just gives you a lot more surface area for the water to flow over that edge. And then instead of collecting the water right at the surface, which could have fish food in it because you have the floating debris or whatever else you've thrown in the tank, I really want to get that water from just a couple of inches down. So I have this baffle in place, and I did the exact same thing in the dome, where I have a baffle and the water comes in through the screen here and then comes up and overflows the weir that's here. One thing I didn't have before was a grate along the top, and I actually had a couple of fish just jump, and they made their way right down into here. So I put a grate on here. And also, if for some crazy reason this grate on the bottom did clog up, the water level obviously would stop flowing here, and the water level would rise up, and then it could just overflow out of this grate before it starts overflowing the tank. So this helps to act to protect the fish and to produce some screening. If there was some catastrophic overflow, it would start catching the debris. And then this pipe just goes down to this elbow. There's a bulkhead fitting holding it in, and then it goes out to the main waste line. And just so you can see the side profile of the tank, here the water would come up through, again, this pipe and just overflow, and there's a bulkhead fitting with this gate valve on here which I can open and close and adjust the flow rate. So just quickly looking at the top view of this tank, I'll try to get it positioned just right here. You can see here that the water from the slough is flowing into this radial flow separator, or radial flow settler as some people like to call it. And then the main water is coming out and it's circumventing the filtration system, and it's going to flow down into the media beds. And that's what all this plumbing is. And I'm only going to show you, the details of the one tank. These two are basically identical. So let's take a look at the radial flow separator settler, and this is a little bit different than what you will typically see. So looking at just the radial flow settler, here's the line coming in. I'll talk about this in a minute. But the water comes in and starts to settle down through this center tube. So the heavier solids will settle down and drop right into the bottom of the cone. And then the slower water will come out, and the goal obviously is to not let the water move as much as possible and get these suspended solids to drop out back down to the cone. And this isn't something that you normally see in a lot of the home-built settlers, is this weir that's in here. And what the goal of that is to distribute the water flow over this entire thing. A lot of these settlers will just have one outlet pipe, and all the water will essentially gush out of that, and it creates a lot of swirls and eddies in the water. So by putting this sawtooth pattern in here, you get lots of little outlets for the water to go out. The trick obviously is to make sure that this is level. Some of the commercial setups, you'll see that this weir setup is actually made into the wall of the tank, and then there'll be like a tray on the outside of the tank. And I didn't want to get involved with having to weld all the plastics, so I actually made up this weir on the 3D printer and printed it out instead. It took several days for it to do it, but I think it's going to work out pretty well. Along the bottom here is the outlet. This is a full drain tank, so there's no little shelf in here. It drains out into this 1-inch line with a valve, a waste line here if I needed to. And then this will head over to the inline mineralization tank. So this is a little bit different than what you would see. Typically you would just see this come out like to a 2-inch ball valve, and the solids would settle down into the bottom of this tank, accumulate up into here, and then every day, usually twice a day, you come out and purge that. But with the inline mineralization tank, the solids are always working their way out of this and going to the other tank, and I'll show that in a minute. I'll show as a I'll do a half profile view here, so you can sort of get an overview of a side view of how the water would flow. What I did up in here, a lot of people, what they'll do is this intake pipe usually comes in lower through the side of the tank and then has an elbow pointing up, and the water sort of overflows the top of the elbow. What I don't like about that is you have that pipe coming through the tank, and the solids will actually settle on that and just sort of sit there. So I'm coming into the top, a little experimental with this, and then instead of just dropping the water right into this and creating a lot of swirls, I'm going to have it hit this diverter plate, have it hit it, and then the water will flow off that and into the sides. I haven't fired that up yet. My main concern is, especially once the fish start getting larger, I'll have larger solids come in, and it could accumulate and get stuck along this. So this is very experimental for me. I may go through a few revisions of that, but currently This is just a 3D printed plate that I made up, and it should help to absorb the energy of that water coming in and then disperse it somewhat evenly into this, slow down that water flow. Then again, the water will allow the heavier solids to settle out down into here, work their way down, drop it right into the bottom of this cone, and then some of the other solids that may still be in the water will work their way up in here and hopefully settle out. I think, I don't remember my calculation off the top of my head, but I was at a 20 to 30 minute retention time, which is pretty good for these standards. And again, this weir is really going to be key to keeping the water from circulating too much. And if you look at sewage treatment plants, they essentially have those large settling ponds, and this works essentially the exact same way by distributing that water. It comes over, overflows this weir, and drops into the channel and then goes into the output. This is just a quick view of that inlet diverter. Two pieces, they snap together, and we'll see how that works out. And then the weir is made up of these 9 pieces, and they just have this little keyway on it, and they slide together, and I just epoxy everything together. And then the whole thing is enamel sealed so that the water doesn't leak into the plastics. 3D printing is not the greatest way to do it, so you have to seal the plastics to keep the water from penetrating into them. But for experimental purposes, it's actually a really good way of making up these parts without having to custom cut the plastics. So let's take a look at the mineralization tank. I currently have one running in the greenhouse. It doesn't look quite like this, but it's about the same concept. This basically looks like a compost tea brewer, and essentially that's what it is, with a few modifications. There's an input for it down here, and this is where the solids and liquids come out of the bottom of the radial flow filter and enter into the system. So overall, the water exiting this is fairly slow. So this is a fairly narrow pipe just to keep the velocity of it moving through, and doesn't allow the solids to settle in this area. And it can be shut off, so if it did clog up with something, I can close off this valve and remove the flexible tubing from it and purge it out. I went with a 1-inch tubing here. The current one has 3/4, and every so often I get a piece of expanded shale or another big piece of debris gets caught in here, so maybe the 1-inch will be a little bit better. So then the liquids enter into here, and this whole tank is essentially filled. These 2 tubes are air lifts, and essentially there's an air stone drop down in here, and it bubbles away and lifts the water up and through and out through here. I did put a flexible coupling in here, and it serves 2 purposes. One, to make it much easier to assemble the setup by having all these glued PVCs. I can put it together. And my other thought was to run the air stone right into this spot and not have the tubing come down into here. And that can be good or bad. If the stone fouls up, then you have to remove all this and drain out the tank to get the stone out, versus just dropping the line down into here. Of course, dropping the line down in here, you have that whole line that's could get fouled up and cause some resistance. So I'll probably initially start the system with dropping a line down in here so I can fine tune it, and then maybe someday, if I get brave, I'll mount the stone into here and not have that line dangling down into here. So then the top part here, the water comes up, the air essentially exits out this way, and the water comes in here. And each side has this 90-degree elbow, which then shoots the water into the tank and will create this swirling motion. And that will just keep the solids moving around, keep them from settling along the bottom. And as they work down, they'll go down through the cone bottom and work their way back up into the tubing. So it's always circulating the solids around and helping to aerate and break them down. So then what happens is the water needs to exit the system somehow. So that way you're always drawing more water in through the bottom. So this isn't really an overflow, but in the side of this part of the tube there is a hole drilled, maybe 3/8 of an inch, not more than 1/2 of an inch, where the water can slowly work its way out of the system and drain out through this pipe out to the main drain. So with that, since it's such slow movement, you have the swirling out here, but inside of this middle standpipe, the water is essentially slowed down, and it really acts as another flow separator. And so hopefully any solids that may have worked their way up into here will settle back down. The current setup that I have, that works fairly well. This one, the water is going to be a little bit more turbulent, so inside of here I may add a couple of baffles just to help slow down the water. So we'll see what happens with that. So let's take a look at the cross section of this. Like I was saying before, the water will come in with the solids through this little entry point here, and then with the air stones at each of these lifts on either side, it essentially draws the water down through the tank and out here, and whatever's coming in here just gets caught up in the water column, and that water gets lifted up. Air vents out through here, water enters into here, and with the elbows it swirls it around inside of the tank, and then just works its way back down and keeps circulating around. Inside of this area, the water does slow down, and like I was saying, I'll probably add a baffle in here just to help it slow down a little bit more. And with that weep hole in the side of this, the water will exit out of this section slowly and then head off to the media bed. So this water, I think the settling time in here is again 20 minutes or so, because the rate of it exchanging through here is so slow. When you want to clean out this, you basically turn off the air stones. It'll stop the circulation. All the sludge will settle down into the bottom. And then I have this nice big 2-inch ball valve, and I could put a tray or something under here, open it up, and blow out some of the sludge that's in it. My current setup, I'm cleaning it out every 3 weeks or so, and so I'm guessing this should be about the same with its clean out time. So peeking back at the drain line once again, we have the clean water coming out of the fish tank through this line. There's also clean water coming out of the radial flow separator from this line, and then the clean water coming out of the mineralization tank out of this line. So they're all ending up in this manifold and draining out and heading off to the media bed. So then at the media beds, this valve would normally be closed and all the water would head off into the beds, and I have it designed to have 6 beds, and then these gate valves here to help regulate. I'm still a little in the open right now on the exact design of this, but I think this is what I've settled on. So basically the water will enter in one of the beds, it'll have media in it, it'll flow through the other side, and then there'll be a bell siphon on the other side, which will then drain into this line and head down to the deep water culture beds. I did add this bypass in, so that way if for some reason I ever wanted to add in some other type of reactor, or just bypass this whole part of the system and dump directly into the deep water culture beds, I have that option just by tying in this extra line. And just quickly looking at the inside of these beds, what I did was put 2 pipes in here. This one will be for the bell siphon. I just didn't draw a bell over that. And then this one is an emergency overflow. That way, if this did get clogged up with roots, this is basically at the top of the gravel level, and if this isn't able to drain anymore, at least the water will be able to drain out of the bed instead of overflowing it. I've had, on rare occasion, maybe a couple of times in the last 8 or 9 years where I've clogged up a bell siphon and it's overflowed the bed. So you know, $20 in fittings here will save a whole lot of aggravation by not having to have these beds overflow. And just to save on some of the more expensive 3-inch fittings, I entered this media bed from this side, did a 1-inch pipe down to this side, or 1.5-inch pipe rather, and draining this side, and that way they both are draining through the center area. One of my original designs, I had this set up where they would drain down into the floor and then head over to the deep water culture bed, but I opted not to do that. These beds are designed for plants that are going to be sort of long-term storage, so there really isn't a lot of need to have to go down these aisles on a daily basis, so I think it's better off to just step over this pipe than to bury it and run the risk of having things settle into that pipe and having to dig up the floor. So we'll just tie it into the system and back to the beginning again. So that's the overview of the whole setup. It sort of looks complicated, but if you break it down to each little individual component, it's really not that bad to have to deal with it. You have a fish tank draining into a filtration system, which then goes into essentially the bioreactor, and this is also collecting up any solids that may be bypassing this part of the system, and then into the deep water culture beds. It comes back and gets pumped back to the tank. The nice thing is that these beds are essentially used as the sump, so there really isn't any digging or having to bury sump tanks in the floor, and the volume in here can just be topped off easily. If that goes up and down an inch or so, that's 1,000 gallons or so per inch that I can make up for, so they shouldn't vary much in elevation. Well, I hope you enjoyed this video. Hopefully you learned a little bit from my thought process behind this design. And pretty soon, within the next few months, most of this should be up and running. Thanks for watching.